The title of the project is Pedestrian Tracking Using Online Boosted Random Ferns Learning in Far Infrared Imagery for Safe Driving at Night. The accident is happened while driving the crossing of the pedestrian. Here in our project, a pedestrian tracking is going to be implemented using online boosted random ferns learning and far infrared camera. The term online boosted random ferns means the boosted random ferns will use instead of the normal distance of the pedestrian. And online means while we comparing the online learning with boosted random ferns means it will improve the performance of the pedestrian tracking when compared with the offline boosted random ferns. And far infrared imagery, here we using far infrared imagery camera because it will work in all illumination changes. In this project we going to focus on the pedestrian at night time. A tracking system is going to happen with an help of FR camera which will produce a thermal energy. The FAR camera is mounted on the forward roof part of the vehicle, which is going to focus on the pedestrian night timing system. Here the pedestrian will detect to those objects should be the main performance criteria, and it also be very effective to face the headlines on the oncoming vehicle. The major cause for this pedestrian vehicle accident is due to inherent drivers, inherent pedestrians, drowsiness of the drivers, poor visibility of the drivers and the pedestrian. A vision technology is applied in this project for this drowsiness monitoring, land detection, obstacle detection, sign recognition, pedestrian detection, tracking to help for us safety driving. In some video surveillance, they have examined that pedestrian tracking will be more challenging because of the moving vehicle and movement of the camera. The pedestrian appearance will be a deformable one and cultured backgrounds, and it will be very difficult for the real-time one. And many studies have conducted to resolve these issues. They told that using near IR, near infrared camera than a far infrared camera will be a very less expensive, and it will have a combination with an illuminator. In the existing system of this project, they used a module to which detect the pedestrian according to the season and the weather, which determined by using a Weber-Fenton's law. It will derive us to help the difference of thermal energy produced by the pedestrian during the summer time or during the winter time. Here the tracking pedestrian to perform at a real-time online learning to track a pedestrian will help us by using a boosted random ferns, which will not use the real measure of the pedestrian, and this updated trackers will be updated in each frame. The link which will help us to detect the position, size, appearance of the pedestrian, and there will be no standard data set for FIR camera for this tracking performance. The previous system has some disadvantages because the temperature will be differ between the pedestrian and the background, which depends on the season and weather, and the accident is obtained also by the collision between a pedestrian and the vehicle. So to avoid this limitation, in our proposed system we implementing a safety night vision driving using FIR camera. In this, the FIR camera is used because of the long wave infrared radiation. The main advantages of this FIR is The utilizing radiation will be as a great range and a wavelength while comparing with the near infrared system. However, a near infrared system will be a less expensive one, but the range and the wavelength is greater in the FIR when it compared to near infrared system. And this system has a thermal imaging camera, a control unit, a display unit, and an optical element. The thermal image will be recorded by the FIR camera, which has a special imaging sensor which will detect the infrared radiation in a specified wavelength range. And this thermal imaging camera will produce a comprehensive image on which the smallest temperature difference can be seen. The temperature difference which happen in the pedestrian or the background will accurately seen by using this thermal imaging camera. In the eyes of the driver, there will be a end product of the good system will produce a timely warning to the driver, which produce the warning of the position of the pedestrian or the overlaid where the night vision will be displayed. The advantages of our project is the utilizing radiation is greater in FIR when compared to near infrared camera. The objective of the pedestrian warning algorithm is to accurately detect the pedestrian, and the information which provide to the driver will be a informative one. The application of this project is here the image is converted by the sensor for the first time, and it will convert to electrical signals, and this aid of the image processing software, it will obtain as a visible image in the control display. The software which you using in this project is MATLAB 2014, that is Mathematic Laboratory, and the tools used in this project is image processing and computer vision. In this project, they are using some techniques. The techniques for pedestrian detection and feature extraction. To detect the pedestrian and to extract the feature of the pedestrian, here they are using some techniques. The first one is Weber-Fin's law, which is used in the existing system. Here in the Weber-Fin's law, it will have a thermal image which contracts the between an object, heat radiation, and the background. The radiation difference between the fore background and the back background will be concluded in this law. For example, the thermal images captured on the night will differ with the image when it captured on the winter season, because in during summer season the body and the part of the head and the leg will be have some less heat, and the body will have some high heat. In winter season the body will have high heat and the head and the leg will have a low heat. So by this comparison, this law is working to detect. And in another system, the feature extracting for tracking, here in this thermal image, the following major criteria will be obtained. That is, it should be in a higher intensity than the background and the individual distant temperature, and the intensity in the thermal image will be a good feature for distinguish the pedestrian from the background and other object, because we have to only track the pedestrian, not the background or the other object. So for this purpose we using this feature extracting for tracking. This two technique is help us to achieve this statement. And the future enhancement of this project is, in future by creating this algorithms, the automobiles company should inbuild this logic in the car itself, so it will automatically detect the pedestrian which comes in front of the car. So by this one we can also increase the standard of set of data